Hey guys, this is A Taste of Science, and today we're talking about emulsions.
Please, nerd, we welcome your stay. You've got no brains in the zombie buffet. When you go out, you order your alien fillet, which is only one of their real. Which comics are better, Marvel or DC? Do you prefer gaming on console or PC?
Hey guys, so the soap earlier is not a great example of an emulsion just because obviously you're not going to eat soapy water. And also, this is not an example of, this isn't supposed to be an episode about cleanliness or washing hands or any of that, but it does show an example very closely related to how we're going to use emulsions later. But first, I wanted to, as we normally do, define what an emulsion is. An emulsion is very simply a blending of two liquids which would not normally mix with one another. As an example, over here I have a raspberry vinaigrette. You can see the two pieces are separated. If you've ever seen most vinaigrettes, they come separate between there. That's the vinegar and the oil. They don't mix, which is one of the big reasons that when you use a vinaigrette of any kind, one of the first things you tend to do, shake it up, right? And while that will temporarily mix them together and allow you to get a blend of the two on your salad or whatever else you're putting the vinaigrette on, that's not going to be a permanent solution. They are going to eventually settle out, separate into their two components, and you'll have to mix them up again. What an emulsifier does is creates a situation in which they can actually intermingle and stay mixed together. Effectively, what it does is the item being mixed into the other one is trapped inside little bubbles of itself, and because it does not bead up and form one continuous layer together, it never ends up separating from the other chemical. In many ways, this is like the liquid-liquid version of a solution. Solutions in chemistry are a solute, like salt or flour, and a solvent, like water. And if you take some water, put it in a container with a lid on it, put some salt in, shake it up, you won't be able to see the salt after a while. It'll just dissolve into the solution. In many ways, that's what we're doing here. When we create an emulsion between two fluids, we're just creating a situation in which they're not going to separate from one another. Now, this may sound like an unusual setup. Why you wouldn't think you see a lot of things which have things that shouldn't mix together and do, and why is this this has to be some specialty thing you don't see a lot in cooking, but it's actually very, very common. In fact, most of you can probably go to your refrigerator right now and find at least two examples of things that are emulsions. You probably just didn't realize it before. For example, a lot of times you'll get vinaigrettes that do have an emulsifier in them that will allow them to stay permanently mixed. Especially if you get a vinaigrette at a restaurant. They've typically added some kind of emulsifier in order to make it easier to serve to guests. So guests don't have to worry about mixing it up themselves since they don't have a bottle to shake or whatever else you use. Other examples of things that you almost certainly have at your house, which are mixtures, mayonnaise and hollandaise sauce. Sorry, those are both egg with I believe oils that are just shaken up. Milk is a very, very common one. It's actually a blend of of milk fat and water. Fat and water don't mix, and yet milk has fat in it without chunks floating around, or at least if it hasn't expired, it has chunks float. It doesn't have chunks floating around. that has a natural emulsifier in it that keeps that fat content trapped inside the fluid. Um, Another example that I'm not a big coffee drinker, but anyone who's a big espresso fan, the foam that they put on top of espresso, that's coffee oil extracted from coffee beans, emulsified with water. It's just a mixture of those two. Um, One of the things, milk was actually the way that we originally discovered um, that emulsifiers exist and things that we previously thought couldn't be mixed together could be. And it's actually why we call them emulsions to begin with. Molliger is the Latin for to milk, um, to, to, to draw milk from something. And so to emulsify something is to in milk it, to milkify it. It obviously not a direct translation, but um, the basic principle is that you make it like milk in that it is a combination of two things that should blend. So how are we using this today? Well, we're going to actually use it, and the fact that it creates kinetically stable systems as our primary effect. Now, what does it mean for something to be kinetically stable? It means that once you put it in a state, it likes to stay in that state. Uh, I'll show you a little bit more about what we mean by that in a second, but a great example is that espresso foam. You're creating foam, and the foam doesn't collapse on itself. The other example might be when I was washing my hands earlier with all the soap bubbles. Water and air don't typically hold like that. If you've ever taken a bucket of water, poured it out in the middle of a driveway, a road, parking lot, your house, if you're willing to clean it up afterwards, um, bubbles don't just form. They don't. The water has too much surface tension. It tries to cling to itself, and it creates a puddle. But with the addition of soap or some other kind of emulsifier, it's able to envelop the air, and it's more willing to do um, that process. So that's the kind of thing we're going to do today. We're actually going to add air into a liquid and create a foam. So I will set that up, and I'll be right back with you guys in a second. So the emulsifier we're using today is called lecithin. It's commonly produced as minus soy oil. Um, uh, it's actually a byproduct of the process of creating soy oil. And it's also found in a number of animal byproducts. In particular, I know that it can be made from the yolk of an egg. And actually, egg yolks are used very commonly as emulsifiers in various things. In particular, it's one of the reasons that we include it when we put oil and water or oil and milk or something in cakes and other baked goods, is to act as an emulsifier and allow those items to mix. So my point in explaining where these come from, if you do want to try creating an emulsion at home, words are not working today, then I would recommend that you be very careful looking online as to where it's coming from if you are vegan or vegetarian, as there are some that are animal byproducts. If it doesn't say, it's probably safe to assume that it is a vegetarian or vegan option, simply because soy is a far cheaper way to produce it than by producing it via an animal-based process, simply because it's a natural byproduct of something we're already creating, rather than taking an egg yolk, which you now can't sell, and using it in order to refine some lecithin. Actually, lecithin comes from the Greek word lethithos, which actually means yolk, because even the Greeks were aware that that had properties of an emulsion And when it was discovered that that was a source of lecithin, they decided to name it after the Greek term for the Greeks having figured out the usefulness of this chemical property of it. It comes as powder. I've actually already added it to my soup here. I'm doing this with some tomato crab soup. You can do it with any soup. You can do it with any liquid. You can make lemonade if you wanted to and do this. I would recommend being very careful. I have a lot of soup in here, and that's a lot of lecithin that I've got to use to actually get anything out of it. And even still, I don't think I'm going to get quite as much foam as I normally would. We're actually creating a foam that can be put on top of something to go with something, and it'll have a lot of the flavor, but it won't be quite as full or quite as heavy, and it's more just as a way of flavoring something else. I'm actually using this as well as the video in 2 weeks, which I'll look at making cooking steak. I'm actually using them to make a variation on surf and turf. So that's why I chose this particular soup. You can do whatever you want for any kind of soup you want, and it should work for all of them. So the hardest part to do for this process is you need to be able to incorporate air into it. If there's no air going into it, then there's no way for the bubbles to form in order to create a foam. I mean, that should be fairly self-explanatory. If there's no air going in, you can't make bubbles. I'm going to use this. It's a immersion blender. It's just like a normal blender, except instead of having a bucket that you put everything in and then blend it, you can blend something in whatever container it happens to be. You can have something on the stove and start blending right there on the stove without having to pour it out, without having to stop the cooking process. They're immensely useful. The other thing is they're very, very fast, which means they're going to be better at incorporating air into a mixture like this than, for example, a blender would be. A blender, the blades aren't getting any air actually down to them, so they're not going to introduce much at all. And then, of course, you could also use mixers with like whisks or beaters on the end. Those will incorporate some air, but not as much as one of these is. It's pretty loud, so I'm not going to be able to talk while doing this, but I'm going to go ahead and mix it up a little bit, and then I'll scoop out a little bit of foam and bring it over to show you guys what this is actually creating. It's basically just going to be bubbles, though. So. Okay. Very, very loud, like I said, but it mixes in bubbles. And as you can see right in here, ooh, I have far too much light for this. Hold on. There's just a foamy mix there. I got a little bit of actual soup in my in there as well. But you can just take this foam, place it on top of whatever you're making. In this case, I'm going to do it as topper for steak, and that's working with emulsifiers and foams. Alright guys, well, I'm going to call it a day. I'm going to go finish up the project for the next episode, those steaks I was telling you about. Until then, I hope you guys have fun in the kitchen, enjoy cooking, and please remember, the kitchen's a laboratory.